Hi everyone, this is Ross from Red Chip Poker. I'm bringing you the 7th video in the GTO Plus course pack. What these videos will do, this and the following videos, will show you how to use GTO Plus to come up with the solutions that you need to have to play optimal poker. Now, if you're like me, you might be a little bit overwhelmed with all the theory in the first 6 videos. And so I'm going to give you a practical way to begin applying these concepts so you can actually have a solution rather than just a bunch of theory. Overall, we're going to start talking about a number of different things about why we're using solvers, what the differences are between Card Runners EV and GTO Plus. And finally, I'll take you through building the Ace, King, Queen, and Ace 5 game so you can actually do that and maybe follow along with Brokos' earlier videos. Now, the reason why we're using solvers, if you wasn't clear, the math is extremely complicated. It's really hard to do the simulations just for the Ace to 5 game. I mean, we can come up with some ideas now that we know what they are to come up with the solutions. But what we have is, hundreds of combinations against hundreds of combinations. It's really hard to do the math there. So we just need computers to do the computations necessary. And it's really good to have these kinds of precision solutions so we can look at what we're trying to accomplish, especially since now players are really trying to get balanced in their play. I think it's very important to learn how to use a solver. So you'll notice that Andrew used Card Runners EV in his videos, and the reason for that is because GTO Plus didn't exist. GTO Plus is made by the same folks who made Krev, and it uses the same engineers. It's just basically the next iteration of Card Runners EV. But the difference is it focuses in on building an optimal solution or giving us the optimal solution rather than the kinds of solutions that Card Runners EV was designed for, which was actually just to build out lines and figure out what your opponents are doing. It was really designed to be an exploitative tool, whereas GTO Plus is designed to be an optimal tool that allows you to run exploitative lines. All the solvers will do this, but GTO Plus makes it very simple to accomplish. And you'll see a pretty simple interface, which is much easier to navigate than actually Card Runners EV is. And we'll look at some details as we go, and you'll understand that basically GTO Plus and Card Runners EV is using the same engine, but GTO Plus really gives us a convincing way to understand, or an easy way to understand, what the optimal solution is, whereas Card Runners EV, it's a little bit more complicated. All right, so let's start working with GTO Plus. This is the screen that you see when you first load up the program. And before you can do anything, you get a little instruction set. It says enter range for playing 1. Range 1, I'm just gonna build our standard range kind of editor that you see in a lot of different pieces of software. Since we're doing the Ace, King, Queen game, we just click on Aces, Kings, and Queens. Gives us a total of 18 combos. You see that here, and later we'll see that change because we're going to do suit selection. So we'll just select clubs and hearts, and then click on Ace, King, and Queen. And now we apply current selection. Here you see the 18 combos, and now we apply current selection. Now it's down to 3 combos. 1 combo of aces, 1 combo of kings, 1 combo of queens. So this is our first player range, the out of position player, and now we'll go to range 2 for the in position player. We'll apply the exact same method to this player. We do our suit selection, apply the current selection, and now we have 3 combos again. And now you see enter board. Our ranges are set, and now we're going to click here on entering board. Since we're doing the Ace, King, Queen game, we're just going to enter 3, 3, 3, 2, 2. Click done. And the next step is to build tree. Building the tree is essentially establishing the starting pot, we'll just add 200 here. And then the effective stacks are 100. So it's a $200 pot, a $100 bet. And you see over here is this geometric growth of the pot bet. So each one of these is the second bet, third bet, fourth bet, fifth bet. It's a simple way to make the same pot size bet on each street, or for each bet, essentially. So on second bet, you see it's a 20.75% pot and 20.67% pot bet. Then we get all the money in. In three bets, it's 13%. And it goes all the way up to five bets, which is down to 7.5%. But we're just going to stick with just the one bet because it's the ace, queen, king game. We have one bet of $100. That's it. Once starting pot, effective stacks, and the betting sequences, you click build tree. And now the tree has been successfully built. And if you look up at the top, you see bet 100 and check. Those are the options. So when we click on one, we see the different actions. Since we haven't solved anything, it's just 50-50, 50-50. Now note that this is only the river. So you can click through all of these lines and you can see different ways, or the different lines, different betting lines that are available. Now, of course, there aren't many betting lines because we only have one bet, but that's how the tree is built. If you look over in the top right, there's a nice little feature called Navigate Tree, where you can just look at the whole tree and what the bets are, what the lines are, what the equities are, and later what the EV will be. Currently, it's not all that exciting because we haven't run a solution, but later this will become fairly interesting, and perhaps it'll be interesting after we run the solver. Let's see. In order to get our optimal results, we're going to have to run solver. So we click run solver, and then we could choose the level of precision that we want. We're going to choose 0.1 because it won't take very long. Deep solutions, you might want to go to 0.5, but this only took 0.23 seconds, so no problems. And so now we have our optimal play. I'm going to click here on the first player and see what their player one is doing. Should be familiar to you. This is what we saw in Andrew's video one. Queens are going to bet a small percentage of the time. Aces are going to bet a small percentage of the time. It will equal 3-to-1 value to bluffs, as we have established or as Andrew established for us in video one. And that's the ultimate solution. And if you look at player two facing a bet, so we click on this betting line, and then we see the responses. When player one bets, player two is going to call with aces and call with 33% of their kings. So again, you see again the 3-to-1 ratio. Even though it's not bluffs to value, it's value to value. It's defense. Now we can look at the navigation tree again. And what we see here are the EVs for each player. So if we hover over one, we get an EV of 94.44 for the out of position player. We can look at each line and see the different EVs for each line, for each player, and each line that each player takes will show us what the EV is. Now you could change that EV if you change the actions of the player, which we'll get to later. But this is a very nice feature to just get the large, broad overview of what the EVs and general betting decisions are, because you see the graph on the left or right, depending on where you hover, and it'll show you what you're supposed to do. It's a good broad overview. Now, when you have a flop turn river, it can get extremely handy to just be able to look at all of the different possible lines and perhaps where players are making mistakes. But let's evaluate one of the questions that Andrew asked in his videos. So let's figure out how to do node locking in GTO Plus. He talked about it in Card Runners EV because of its ease. It's actually even easier in GTO Plus. And that's going to be something that we rely on significantly in the next two videos. But let's see if we can take a look. When you want to lock a node, you just click on Lock Edit Decision. And then you can just change all the decisions that your player makes. So one of the questions that Andrew asked is, what would happen to player one's betting range or betting frequencies if player two, instead of calling optimally at 1/3 of the time, instead called with kings 25% of the time? So let's look at how this gets solved. So we click on Fold here. Essentially, we're looking to find what the highest EV response is to this player type. So if you click on the bottom at current selection, you can change the call and fold percentages. So I'm going to set call percentage to 25%, fold percentage at 75%, click done, and then I can just go up here and click on King King. Right now you see King King is 0.33% or 0.33 of his combos, and now King King is only calling with 25% of its combos. So we've changed the frequency with which the in position player calls with kings when facing a bet. So that's what we've locked in. So you see this little lock sign that tells us that the node has been locked, that particular node. We've changed the player's frequencies, and now we're going to run the solver again, and GTO Plus will tell us what the proper response is for player one. So now we've run the solver, and if you notice, player one is betting 33% of the time instead of 27%, and as we might have guessed, queen is betting 100% of the time. Ace and king are always checking. You may remember why this is, but if you don't, the point is King King is not calling often enough. Since King King is folding too often, it's the highest EV play is now to just bluff, because King King is folding too often. Ace Ace, it doesn't make sense to bet because King King is folding too often. So we want to pick up the value from King King when it bets, when we check to it, as opposed to having it fold when we bet with Ace Ace. So this is one of those examples where you see that the optimal solution is to bet 100% when the opponent is making a large enough mistake. So bluff 100% when the opponent is folding too often. Now this is an extreme example, but that is how we do this kind of analysis, and that's how node locking works and how we can utilize it in Card Runners EV, or in GTO Plus, sorry. So you can click back on analysis mode and then just rerun the solver again, and GTO Plus will just revert back to the original optimal solution. Now let's follow one more node locking example, and you'll then have kind of the full spectrum of the ace king queen game, and it'll allow you to be able to mess around with it yourself and sort of go back to Andrew's videos and sort of plug in different things so you can see different kinds of strategies. So here I'm going to follow the other example I gave and just lock in ace ace. His point was that it's often possible for an optimal solution to make a profit even though it's an optimal solution. The perception, of course, is that it's only a break-even strategy, but with big enough mistakes, it actually profits. So the question is, what happens if player 2 always folds the nuts to a bet? So we'll change it. We'll lock in aces as a fold, always folding. We'll run the solver and see what the highest EV solution is. Now you notice that, of course, we're always betting, or player 1 is always betting. There is no checking line for the out of position player because the in position player is simply folding so much there's no reason to bet. So if they're going to fold the nuts, it's always profitable to bet. And if you look here, the EV that was 94.44 is now $188. So that mistake was massive, combined with the optimal adjustment, makes this an almost perfect extraction of expected value. One other thing we can do is look at how the optimal state works in this same scenario. Now, optimal being that assuming that the other player is playing optimally, we're going to lock in all of the solutions that we want to play. So now we're going to just lock in everything that we want to be the same. So we're going to make ace-ace 100% fold. But instead of changing the strategy to exploit that, we're just going to stick with the previously determined optimal strategy and see. And what you see is the EV is 104.7 So we went from 188.8 to 104.7. So it's not we're not hugely profitable. We're giving up a lot. At the same time, the exploitative line, or at the same time, the optimal line still shows a profit. But it was a significant reduction in our potential EV had we actually exploited the mistake that our opponent was making. But the optimal strategy does produce a profit. So that brings us to the end of building out the ace, king, queen game. And now the next step is going to be to walk through how we do the ace to 5 game. It should seem fairly simple now that we've done the ace, king, queen game. Give me a sec and I'll open up another GTO Plus window and we'll deal with the ace to 5 game. All right, here we are. This is going to follow almost exactly what we did with the ace, king, queen game, except for we're going to add jacks to 5s, right? But if it's not obvious to you, then just keep poking around with the software, follow this video, try to play along with the video. It should be second nature to you in an hour. It's fairly simple. So here we go. We're going to select all the suits for aces to 5s, and we have a total of 10 combos once we apply the solution. And now we do the same thing for player 2, and it's just the same process as we did at ace to king. And it's essentially like working with Flopzilla. If you've ever looted Flopzilla, however you engage with it or however you can understand it, that's all you should be looking for. All right, so here we are. We're entering in the board. Now we're going to build the tree just like we did before. 200 and 100, got one bet, build tree. Okay, now here we are. Now let's run the solver. Took us 0.25 seconds this time. And let's peruse what all the possibilities are. This is the same results that we would have gotten from Card Runner's EV, just as Andrew showed us. So you see player 1 is indifferent between 5s and 6s. When player 1 checks, player 2 is always going to be bet 5s, jacks plus, and be indifferent between 10s and 6s. And this is as simple as it gets. I mean, it's fairly easy to do this. You should be playing around with node locking and see how things change, and maybe try to apply different bets to this scenario. Maybe you add in the raises or the raising decision that Andrew did with in his last video, and like try to get this into GTO plus. You can sort of mess around with different locking nodes. How would it change if pocket fives are always bet by player one? But notice that the increasing combos, the EV, has actually reduced for player one. So at this point, we're at 93.89 EV as opposed to 94.44. So it didn't lose a lot, but we still lost some EV by adding more combos. So the more decision points there are, the less EV you're going to have. And this is all I wanted to show you in this video, just so you have familiarity with the software that ships with the course. And I want you to have this simple entry point to begin working through GTO plus. And you can, sort of now use this to actually model his theory in practice through GTO plus. That brings us to the end of this video. I suspect you should be able to build the ace to 5 game yourself and the ace king game yourself, or ace to queen game yourself. In the next video, we're going to talk about building real poker strategies using this software. So in the next video, you actually get real poker work done. And this should help you move forward with your game theory optimal approach to poker. Okay, see you in the next video.